Hi, so I am Professor Sheetal Silal and I'm an Associate Professor at the University of Cape Town in the Department of Statistical Sciences, which is in the Faculty of Science. And I'm also the Director of a research unit called the Modelling and Simulation Hub Africa. And what that research unit does is we focus on using computers and simulation to build models of disease so that we can help people like government make better decisions on how to manage diseases like COVID-19, which we're experiencing at the moment. So I grew up in a little rural town called Verulam, just north of Durban in Kwazulu-Natal, and it's a little farm town, and I was lucky enough that I was able to go to a school in the city where I had a lot of opportunities to extend my range of thinking and to help improve my environment, and I did really well in maths in school, and that helped me get a scholarship to go to the University of Cape Town. And at the University of Cape Town, I started doing a degree that was strong in maths, called actuarial science, but it was a finance degree. And I enjoyed it, but I knew that maths was my real passion. And I didn't want to end up or to start working in a finance corporation. I wanted to do something meaningful with maths. And that's when I got a scholarship from the National Research Foundation to take a master's degree. And in that master's degree in the Faculty of Science, I learned how to use maths to solve everyday problems. And I stumbled upon solving these problems in the disease world. So if you have a disease and you want to, say, introduce a new medicine, or you want to introduce a new vaccine, the impact of the vaccine, the cost of the vaccine, is it going to be useful? I learned that I could use my maths to help governments answer those kinds of questions. And that was really the hook that kept me in that field. After my degree in mathematics, the National Research Foundation again supported me to do a PhD and some research post-PhD as well, and I became a lecturer in the University of Cape Town and have been on an upward trajectory since. And so right now I'm an associate professor. So my field of research is infectious disease modeling. Now, what that means is we use mathematics to help understand how diseases behave and how they spread in a population and what we can do to control diseases. Now you think, diseases, isn't that about medicine? What does maths have to do with anything? But we have to understand that it's not just about the having a disease, it's about, can you seek care at a clinic or go to a hospital? Do you have access to receiving the appropriate treatment that you need? And so we build all of these characteristics, all of these features of the health system into a model, and we use mathematics to take the behavior of disease and translate it into a set of equations. We then solve the equations and we build something like a video game, a simulation of how a disease behaves in a population, and then we use that simulation or that model to answer questions. So if we want to roll out the vaccine, like with the COVID vaccine we're doing at the moment, we can answer questions like, what impact will the vaccine have in reducing cases, in maybe preventing a fourth wave, or making a fourth wave to be less severe than the other COVID-19 waves have been. So you can see now that we can make these experiments on a computer, and that becomes a lot more cost-effective or cheaper to maintain, rather than trying to experiment on a population and do a survey. So that's really what infectious disease modeling is about. And one of the benefits, the prime benefits of disease modeling, is that when you work with governments or decision makers like governments, your work gets to have a direct impact on improving people's lives. And there have been many, many instances where our work has been adopted by government, and it's changed policies, and it's informed things like restriction levels, for example, and that helps to improve the lives of people and to save people from getting unnecessarily infected by infectious diseases. So there's a direct link here. For the first time, perhaps we can see it, a direct link between maths and computers and then saving lives. So a typical day of work as an academic at a university involves two things. It involves teaching and it involves research. They're not always happening at the same time, but from time to time they do. So I lecture to some undergrad students. I mostly lecture to postgrad students. So that would be your master's level students, teaching them courses in advanced mathematics and disease modeling. So I may spend an hour or two preparing for your lectures and then delivering your lectures and answering queries from students. But the majority of my time is spent doing research and doing this disease modeling. What that means is I mostly am sitting in front of my computer, but I am coding, so I'm doing computer programming and building up these models. I am analyzing data like our COVID-19 cases and our hospital admissions from COVID-19, and I'm working with my team in research. And my team, we're a group of multitude of skills in science. So while my primary skills are in statistics and mathematics, I have other computer programmers on my team, I have health economists on my team, and we work with many others in science. So we work with biologists, we work with government and public health specialists, we work with vaccinologists and doctors, clinicians, intensive care doctors. So we work with a range of people in health in order to help approach our questions. One of the primary benefits, I think, of having an academic position is that you have many opportunities to travel. And so COVID-19 means that travel has been quite restricted, but prior to COVID-19, in a typical academic life, you do have many opportunities to go to conferences, to go to research meetings, and in fact, much of my infectious disease modeling work has been global. So it has been with my teams, with my collaborators in the Asia Pacific. So in many countries in Asia, in many countries in South America, in countries in Europe. So you get an opportunity to travel to all these wonderful and exciting places to pursue what I love, which is to use disease models to help improve the health of a nation, whichever nation that is. So one of the first projects I did after graduating with my PhD at University of Cape Town is I was invited to lead a modeling project at a global level. It was for 22 countries in Asia, in the Asia Pacific region. And what we were trying to do there was to understand if malaria elimination is possible. Now, malaria is a disease that is treatable and it is preventable. And yet there are millions of cases every year. People get really sick from malaria and a lot of children die from malaria. But we should be able to get rid of the disease. The question is, how will we do it and how much will it cost? So I was asked to build a model, not just for one country, but 22 countries in Asia to determine what are the possible ways in which malaria elimination can be reached and how much is it going to cost. And this work was then communicated to many governments within the Asia Pacific to help them plan their strategy to achieve malaria elimination. So that was one opportunity I had to work outside South Africa, and I've had very many similar opportunities because we are not the only ones suffering with certain diseases. So COVID-19, we know the whole world is suffering, and so modeling is not just helpful to South Africa, it's helpful to the rest of the world. So during the COVID-19 pandemic, I was not just supporting our government in South Africa to provide scientific evidence from modeling, I was also helping Mozambique, I was also helping Namibia, and in that way we can work together to improve the health of the continent in the spirit of Ubuntu, and I think that's really important when conducting our research. So at the time I was growing up, it was not normal for girls to just be getting into scientific subjects or into scientific fields, and girls were not often promoted to doing so. And I was lucky that my parents always encouraged me to do whatever I wanted to do, and they didn't stop me. But I know that that is very difficult for a lot of people. So I would say that you have to work really hard because the world is not set up to be equal for everybody. And we know that many of us are historically disadvantaged in South Africa, and we have to work through that disadvantage. And in trying to make the world a better place for the future, to do the work that I've done and to get as far as I have, it really has meant working so hard in school to get as high marks as possible, to get a scholarship to go and study after school, or to study into a master's degree. You really have to keep working hard at the same time as taking all the opportunities and doing the best you can, giving it your best every single time. And that can be tiring. We know that we have so many, we have so many issues sometimes, with family, with our environment, and it becomes hard to push and be the best all the time. But if we do persevere, we become better adults for it, and it helps you to get further in life. I think the goal, though, especially in South Africa, is that it's our responsibility now as the if you guys as learners are the future scientists, I'm one of the current scientists, but it's our job now to help empower the nation to create a better world where historical disadvantage doesn't matter anymore. That's the real goal. So one of the things that I pursue a lot in my research unit is capacity building. So I focus a lot on working with school learners and university students to pick up their skills and improve their skills so that they can become modelers like me and hopefully far better than me in the future. So at school, one of the life-changing events for me was getting involved in debating. And I started debating in school in grade 7 and continued all the way through to matric. And I was lucky enough to be part of the very first group of students to win the national championships in debating. But the best part about debating is that it proved to be so useful later on in life, in that it helps you gain confidence in learning how to present and to communicate effectively. And we know that in science, that's one of the overlooked skills that scientists should possess. So debating is not just about learning to talk, it has a multitude of greater benefits, like building confidence in your abilities. So I think what is most beneficial or the best advice that I can give to students is to take maths and to take your science technology type subjects in school, because the greatest benefit of science and the greatest benefit of maths is not the subject itself, it's how it teaches you to think. And that is the most important part, because as a doctor, you need to diagnose a certain illness. You've got to follow a logical process. As a lawyer, you have to unpack so much of evidence to create a clear story or identify what the truth is. And those skills are actually best developed by mathematics, because mathematics teaches you how to problem solve. And that is for me, I believe the primary reason why students, learners at school should be taking maths and science, not just up to grade 9, but all the way up to matric. And then, aside from or outside just the subjects that you take, I think it's important to be a go-getter, to take every opportunity that comes your way. You will not be able to progress very far if you wait for opportunities to come to you. So you need to go out and look for them. Now I know that can be difficult, but there are places where you can ask and you can seek assistance. You can ask your teachers for advice. If you have access to the internet, that is really the whole realm or the whole world of information. Easy places to start looking are the NRF, the National Research Foundation website, the NSTF website, the university websites. On all the university websites, you can go straight to the Faculty of Science and you can see what departments are there. You may not understand any of the names of the departments, but that doesn't matter, because each department will have a description what it is about. And the more and more you read, the greater your world will expand and help you to see that there is something for you in this world that will really make you happy and help you to earn a living at the same time. What I enjoy most about my job is the problem-solving aspect, that every country is different, every disease is different, every health system is different. So building a model is different every single time. And the very best part about the work I do is not just enjoying the science of it, is that I get to see our work have a real impact. It gets to be translated into policies. We get to to secure funding to buy new drugs to help eliminate disease. And when you can see your work having an impact in improving the lives of not just 1 or 2 people, but millions of people, that is all the incentive you need to be happy and wake up every morning and be excited about your job.